Page 3 of the addendum for discrete random variables for HL. Number 1. Suppose that x has the probability distribution as follows. Find the mean of x, the variance of x, and the standard deviation of x. Okay, so we're going to just do this with the calculator, and then we'll talk a little bit about how you do it by hand. Okay, so the mean of x and the variance of x and standard deviation of x, all the information you need for those appears in the output of the calculator. So let's see how we do it. We do stat edit, and we're going to input 2 columns of information, x and the probability of x in each one of these. So the first column is going to be just x, so it'll be 2, 3, 4, 5, 6, right? The second column is going to be 0.3, 0.3, 0.2, 0.1, 0.1, 0.3, 0.3, 0.2, 0.1, 0.1, right? And do stat, calc, 1-var stats. Why is it 1-var stats and not 2-var stats? 2-var stats is used when you have an x variable and a y variable. Here we don't have an x variable and a y variable. We just have an x variable, and we have a proportion of how often the x variable turns out to be whatever it is. So we use 1-var stats. In the frequency list, in this case, since we do have the proportion of what when it becomes each number, we put that in as the L2 value. So second 2 gives us L2, and then we calculate. And x bar 3.4 is obviously the mean. So the x bar value is the mean. And then we can see later that the sigma x value is the standard deviation. So for sigma x, we put 1.28. Okay? What about the variance? We look all over the list for variance, and it's not there. But actually, remember that variance is the standard deviation squared. So we can find it by doing 1.28 squared, which is, use the calculator again, it's 1.64. Okay? So now how would you have done this by hand? So what you would do is, for the mean, that's something we've done in other problems. But basically, you just take each one of these pairs and you multiply them together and then add them up. So you would say the mean is equal to 2 times 0.3 plus 3 times 0.3 plus 4 times 0.2, etc. See, that's pretty easy, right? You just do all those multiplications and additions. It's kind of a pain if you have like 50 numbers, but if you only have these numbers, you could actually do that on the exam, right? And probably this would be on the calculator exam. So I don't, the way they force you to do this without the calculator is they give you like a couple of unknowns like x and y, and then you're forced to do it kind of with algebra. What about the variance of the standard deviation? So the way you do the variance or standard deviation, I think the easiest way is, instead of multiplying each one of these pairs times the data itself, you're going to square each one of these. Okay? So let's say you're doing the variance, which normally you would do first. Okay? When you do it manually, the variance is easier to calculate because you first find the variance and take the square root of it to find the standard deviation. So the pattern here would be sigma squared is equal to 2 squared times 0.3 plus 3 squared times 0.3 plus, and so on, okay? And after you do all of that, you're going to subtract mu squared, okay? And mu squared you already found in the first part is 3.4, right? So instead of subtract mu squared, you would actually do minus 3.4 squared. And that would give you sigma squared. How would you find sigma itself? You would just take the result there, and you would take the square root of it, and that would give you sigma. Okay? So maybe the trickiest part is finding the variance. And remember that there's formulas for the variance on the formula sheet, and they would say something like, okay, there's a couple of options. One is that you could take the expected value of x squared and subtract mu squared. And the other is you could take the expected value of x minus mu squared. And if you're like manually calculating it, then probably you would do it this way, okay, and not the other way. Because then, do you see how, like, if you did it this way, you would actually have to subtract mu every single time, which would create like weird numbers. Instead of nice numbers like 2 squared, 3 squared, 4 squared, you would have like 2 minus, 3.4 squared and stuff. So normally we prefer to use this formula here, which is equivalent. So usually we'll just find the average of x squared, and then we subtract out mu squared at the end. Okay? All right. Number 3. Suppose x has the probability distribution as follows. Find the expected value of x, blah, 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 blah. So now we're going to use some of the rules that we learned before about how to use the fact that we know the expected value of a number to find the expected value of the number plus 1, etc. Okay? So first, let's use the calculator to find the expected value of x. Like we saw before, the way you do it is you just multiply these two, multiply these two, multiply these two, multiply these two, and add them all together. But the calculator usually does it using stat edit. So the numbers are 1, 2, 3, 4. Let's see. We'll do an insert and we'll put 1. So then we can use these and we'll delete the last two numbers. So we'll have 1, 2, 3, 4. And then we'll go to the other column and we'll do 0.4, 0.3, 0.2, 0.1. So we'll do 0.4, 0.3, 0.2, 0.1. We'll delete this last one. It's perfect. It's done. Okay. So then we'll do stat calc, 1var stats, L1, L2 calculate, and our x bar value is 2. So we know that the expected value is another way of saying the mean. The expected value of the random variable x is 2. Oh, look at that. Did you see that this also gives us the expected value of x squared? It says it's 5. So actually, the expected value of x squared is 5. Okay? So we already have 2 of these answers. And if we know that the expected value of x squared is 5, we can also figure out the variance by taking 5 and subtracting the expected value of x squared. Remember, like this formula right here? Okay, so that gives us 5 minus 4, which is 1. So actually the variance is 1. There's another way we could do it. We could look at the sigma value, which is standard deviation, and we see that the sigma value is 1, so that means sigma squared has to be 1 also, right? Okay, what about the expected value of x plus 1? If we add 1 to every one of these numbers, which would make it, instead of 1, 2, 3, 4, it would be 2, 3, 4, 5, and then we took the average of all those, you can see that raising each one of the individual numbers by 1 is going to raise the mean by 1. And that's what the rule also tells us. The rule says if we add k to the random variable, that the mean value is going to be the original mean value, 2 plus k. So it's going to be 2 plus 1, which is equal to 3. What about if we take the variance of instead of x, the variance of x plus 1. Now remember that if you take a certain distribution and you add 1 to every one of the numbers, basically what that does is it shifts it over by 1, right? So we'll get the green ones to the red one. But has the width of the function changed? No, it hasn't. So if the width of the function hasn't changed, the dispersion hasn't changed, so the variance hasn't changed. So that would mean that the variance of x plus 1 would be the same thing as variance of x, which is 1. For this last one, remember that if you have the expected value of 2 different random variables, it's the same thing as the expected value of one variable plus the expected value of the other variable. So this complicated looking function here is actually 3 simpler functions added together. And some of these are trivial, okay? The expected value, If you always get -7, what's the expected value? It's -7. So this last one is just -7. The expected value of 3x is the same thing as 3 times the expected value of x. What's the expected value of x? The expected value of x is 2. So it would be 3 times 2, or 6. And the first one, the expected value of 2x squared, is the same thing as 2 times the expected value of x squared. 2 times the expected value of x squared is 5, right? So that means it's 2 times 5, which is 10. So it's 10 plus 6 minus 7, which is 16 minus 7, which is 9. That's it, okay? Number 5. Suppose x is the number of marsupials entering a park at night. It is suspected that x has a probability distribution of the form a x squared minus 8x, where x equals 0, 1, 2, 3, 4, 5, 6, 7, 8. Find the constant a. Okay. All right, so this is usually the first question they always ask when they ask a probability distribution problem. And what they're doing is they're saying, does the student know that the probability distribution function, something like that, has to have an area that sums up to 1 because the probability of anything happen is 1? So if you know that, this is a pretty easy question. Okay, so basically we're going to say, okay, we're going to have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and we're going to plug it into this equation, and we're going to make sure that we're going to add it up to 8. So I'm going to make a table, and the table is going to have all the numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then the a value is going to always be present, right? So the 0 value, the probability that 0 is going to happen is going to be 0 minus 8 times 0, which is 0, times a, which is 0. Okay, so the probability of 0 happening is 0. What about 1? That would be 1 squared minus 8 times 1, which is 1 minus 8, which is -7, so it would be -7a. What about 2? If I put 2 in there, it would be 2 squared minus 8 times 2, which would be 4, minus 16, which is -12a. 3. If I put 3 in there, it would be 3 squared minus 24. So that would be 9 minus 24, which would be -15a. What if I put 4 in there? 4 squared minus 4 times 8, that would be 16 minus 32, which would be -16a. What if I put in 5? That would be 5 squared, which is 25, minus 40, which would be -15a. 6. What if I put 6 in there? It would be 6 squared, which is 36, minus 48, which is -12, -12a. Starting to go back down again. If I put 7 in there, it would be 49 minus 56, which would be -7a. And if I put 8 in there, it would be 64 minus 64, which would be 0. Okay? So I can see now that a is going to be a special number, because do you see how all the coefficients are negative? All the probabilities have to be greater, 0 or greater. Otherwise, it makes no sense. You can't have a negative probability. So I know that a has to be a negative number from looking at this, don't I? Okay? So now I'm just going to do a little bit of algebra. I'm going to add up all of these probabilities, not knowing a yet. And so it'll be -7, minus 12, minus 15, minus 16, minus 15, minus 12, minus 7. And that will give me one big coefficient multiplied times, let's see. Okay. One big coefficient. So I'm going to do 7 plus 12 plus 15 plus, okay, I'm just going to add those up for now, those first three, and it'll give me 34. I'm going to multiply times 2 because there's 2 7s, there's 2 12s, there's 2 15s, so that's 68, and then I'm going to add it to 16 because there's only one of those. So it's going to be -84. So for a, I know that -84a is equal to 1 because all the probabilities added together equal 1. So a must equal to -1 over 84. Okay, and so I figured out the value for a. because it has to be negative 1 over 84 so that the probabilities all add together to become 1. Find the expected number of marsupials entering the park on a given night. Okay, so what I'm going to do now is I'm going to put in all the numbers into the calculator. So I'm going to have, I don't need 0 and 8 because those values are 0 anyway, but I could put 5, 6, 7 for the first column. And then for the second column, I'm going to put in the probabilities. And the probabilities are all something divided by 84, right? So I got 7 divided by 84. It's the first one. And the next one is 12 divided by 84. And the next one is 15 divided by 84. And the next one is 16 divided by 84. And then I repeat again, 15 divided by 84. And 12 divided by 84. And 7 divided by 84. Okay, and then I'm going to do stat calc, 1 bar stats, L1, L2 calculate, and that gives me the expected value of marsupials would be 4. It's exactly 4. That makes sense, right? I mean, now I feel kind of dumb because, like, if you look at the distribution is symmetrical and it's centered at 4. So of course the mean or number of marsupials, the expected number is 4. Okay. Next, find the standard deviation. Okay, I couldn't have found that without the calculator. But so if we do stat calc, we could find the standard deviation, which is 1.73, right? Okay. All right. Now, could you have found the standard deviation manually? Yes. The way you do that, of course, is you use the formula expected value of x squared minus mu squared. So mu is 4, so that would be 4 squared, and the expected value of sigma squared. You would just take this table, and instead of multiplying together 0 and 0, 1 times 7 divided by 84, etc., you would just square every single one of these numbers before you multiply it times the probability, before you add them together. Okay? Number 7. A box contains 10 almonds, 2 of which are bitter and the remainder are normal. Britt randomly selects 3 almonds without replacement. Let x be the random number variable for the number of bitter almonds Britt selects. Okay, 10 almonds, 2 of which are bitter and the remainder are normal. So every time he chooses an almond, there's a 2 in 10 chance that it would be bitter, or 0.2 chance that it would be bitter. He selects 3 almonds without replacement, so interesting. So the first time he chooses the almonds, it's going to be different than the second time, etc. Let x be the random variable for the number of bitter almonds that Britt selects. Okay, so this is pretty complicated. We're going to have to make a probability tree for you guys to actually see what each possibility is. This is pretty complicated. So we're going to make a probability tree, and it's going to have 3 layers because there's going to be 3 draws. Okay. So the first draw, we have a 0.2 chance that we're going to choose bitter, and we got a 0.8 chance that we get normal. And the second draw, since we had a 2 in 10 chance on the first try and we got a bitter, the second chance to get a bitter again, we only have a 1 in 9 chance. And to not get bitter, we have an 8 in 9 chance. And then if we chose a normal the first time, the chance to get a bitter is like 2 in 9 because we still have 2 bitters. And then we have a 7 in 9 chance to get a normal. And then in the third layer, we got we don't have any chance to get a bitter again because we've already chosen the 2 bitters out. So we know that on the second or the third draw, there's a 0 chance of getting a bidder, and there's a 1 chance of getting a normal. And if we only chose 1 bidder, then there is a small chance of getting a bidder again. It would be 1 out of 8, and there is a 7 out of 8 chance of getting a non-bidder. And then on this one, let's see, if we already chose 1 bidder, again, we have a 1 in 8 chance of getting a bidder. And we have a 7 in 8 chance of getting a normal. And then in the bottom one, we didn't choose any bidders yet, so we got a 2 in 8 chance of getting a bidder, and we got a 6 in 8 chance of getting a normal. And then now what we need to do is we need to tally up every single one. So the first one is 3 bidders, but there's a 0 chance of that, so we won't even write it down. The second one, we got 2 bidders and then a normal, and the chance of that happening is 2/10 times 1/9 times 1, which is 2 over 90. And then the third one is bidder and normal bidder, and there is a 2/10 times 8/9 times 1/8 chance of that happening, so that would be 16 16 times 90, 16 on top and 90 times 8 on the bottom, which would be 720. And then the fourth one would be BNN. So that would be 2 times 8 times 7 on top. And so this 2 is actually 2/10, right? And 8, I'm going to rewrite those as 2/10 because it's better to do with fractions. So this would be 2/10, and this would be 8/10 on the bottom. Okay, so BNN would be 2/10 times 8/9 times 7/8. So that would be 16 times 7. So the numerator is 2 times 8 times 7, which is 112. And the denominator is 720. And then the fifth one is NBB, which is 8 times 2 times 1, which is 16. And the denominator is the same. And then the next one is NBN, which is 8 times 2 times 7, which is 16 times 7. We already calculated that, so it's 112. And the next to last one is NNB, which is 8 times 7 times 2, which is 112. And the last one is NNN, which is 8 times 7 times 6, which is 8 times 7. So that 8 times 7 is 56. And 6 times 6, 336. And that's divided by 722. And the first one, which is 2 divided by 90, if I wanted to change that to a denominator of 720 to make it a common denominator, I would just put multiply the top by 8, so it'd be 16 also. Okay, so, and I'm just going to color, like, let's see, the one with no bidders would be yellow, and the one with 1 bidder would be orange, and the ones with 2 bidders are red. So those are the 3 possibilities. And so now we've done all that work. We found the probability. Well, let's find the probability distribution expressed in terms of number of bidders. So so we'll have 0, 1, or 2 bidders. Okay, and the probability for each one, let's see, 0, the probability of 0 bidders is 336 divided by 720. The probability of 1 bidder would be 112 plus 112 plus 112, which would be 336. Oh, it's also 336. And what's the probability of 2 bidders? The probability of 2 bidders would be 16 over 720 plus 16 over 720 plus 16 over 720, which would be 48 over 720. Okay, so that's the probability distribution of x. That's A. B, find the mean of x and the standard deviation of x. Okay, so this is, you could multiply those out and do it by hand, but why don't we just do it with the calculator? Okay, so stat, edit, and I'm going to clear these, and I'm going to clear these, and I'm going to put 0, 1, 2 down the first column, and I'm going to put 336 divided by 720 here. I'm sure that can be reduced, but I'm going to put the same thing here. 336 divided by 720 here. And then the last one's going to be 48 divided by 720. And then I'm going to do stat calc, 1-bar stats, calculate, to find the mean, which is 0.6. Okay, so the mean is going to be 0.6. The standard deviation is going to be 0.611. Okay, and you could do that by, finding the sum of the products here. That would give you the mean. And if you did 0 squared, 1 squared, 2 squared, and subtracted the mu squared, you could also find the standard deviation by hand also. Okay, and that's the end of page 3.